In this video, I would like to discuss the root test. So when do we apply the root test? The problem is most of the time the problem won't tell you that, hey, apply the root test, tell me if the series is convergence or divergence. You have to know this yourself. So when do we apply the root test? We apply the root test when you see the entire series is raised to the nth power. Sometimes the problem will just give you the nth power, but in most of the time, you have to work on the exponent a little bit to get the nth power out. So either you see it or you have to work it out using one simple step. All you have to do is you use the law of exponent. So in this video, I would like to discuss the concept of ratio test, and I would like to give you the three possible cases. Again, you use this test when you have the entire series raised to the nth power. So let's review the exponent and the radical a little bit. So first we have n squared, right? So n squared, if I take the square root of n squared, the square root cancels with the square, right? Because the square root is the same thing as 1/2 power, and then 1/2 times 2 is n raised to the first power. So in the middle, I have n raised to the third power. If we take the cube root of that, then we go back to n. So what if we have n raised to 100 power? Then you have to take the 100 root of n to the 100, then you get back to n. So we have a series an, and I want to check the limit as n approaches to infinity. What is this trying to do? We are trying to check the nth term. Remember, a series is the sum of a list of numbers from the first one to the very last one. I have many numbers. I want to add them up. Now, what happened? Now what happened? So I want to check the nth term. So we have a list, right, from the left to right, from A1 all the way to AN or A infinity. I want to look at the last couple numbers. What happened when n approaches to infinity? So the last couple numbers, are they really a big number or they are just a zero? So if they are zero, it looks like when you reach to the end of the addition, you are adding up a bunch of zeros. So therefore, the series most likely will be convergent, right? Because the sum is a real number and the sum is determined by the first couple numbers. If you check the nth term and the nth term, they are big values. So let's say something huge, 1 million or infinity. So that means if you keep adding numbers or you keep adding stuff up, so that means you will be adding infinities when you reach to the end of the summation, which means the sum will be equal to infinity. So therefore, the series is divergent. So there are three cases. I want to let the series itself, the body of the series, be a fraction. So the fraction means we have a top divided by bottom, right? So fraction, think about rational function. You have a function on top, you have a function on the bottom, you have the top divided by the bottom. So there are three cases. The first case is when you check the limit, the top divided by bottom, the limit is less than 1. So as n approaches to infinity, we have top divided by bottom, which means the result of the limit is less than 1. So top divided by the bottom is the body of the series, right? We take the limit of that. So we are taking the limit of a rational function. We are checking what the limit equals to. It turns out the result is less than 1. What does that mean? When the result is less than 1, so here is what we have. When the result is less than 1, the best way to analyze this is using an example. Let's say the top is equals to 1, the bottom is equals to 5. So top divided by the bottom, 1 divided by 5 is less than 1, right? And then what is this term? This is the nth term. So that means we are adding up small quantity. Small quantity of what? You have a list of numbers, right? You look all the way to the right, you are adding up the last couple values, and they are pretty small quantities. So that means the sum is equals to a real number. So the series is convergent. And then the case in the middle, we have top divided by the bottom greater than 1. That means the top must be greater than the bottom. So let's say we have 5 divided by 1 that is greater than 1. All right. So as you look all the way to the right, the last couple term of the series, you are adding up large quantity. In that case, most likely, the sum is equal to a very large value, and therefore, the series is divergent. All right, what about the third case? The third case is the top divided by the bottom equals to 1. So we have 5 divided by 5 equals to 1. Using the root test, this one is no conclusion. All right, so let's generalize this into three cases. So the root test is applied when you have a series raised to an nth power. So either you see that straight from the problem, or you have to use the law of exponent to get the nth power out. So there are three cases. Case one is you take the nth root of the series, and it turns out that the limit is less than 1. That means the series is absolutely convergent, and therefore just a convergent. So just like the first cases, the limit is less than 1, so that means the quantity is pretty small. You are adding up a bunch of very small quantities. Maybe 1/5 is not small enough, so think about 1 over 1,000, 1 over 1,000,000. So you are just adding up a bunch of numbers that are so close to 0. Therefore, the sum or the series, the sum is really determined by the summation of the first couple numbers. So therefore, the series is convergent. And then case 2, the limit is greater than 1, so that means the last couple numbers you are adding up pretty large quantities. As a result, there is a very good chance that the sum is equals to infinity, and therefore the series is divergent. The case 3 is so rare, you really don't see one problem like this on the book. Is the limit is equals to 1, the root test is inconclusive, we are not able to reach to any conclusion. This is very rare. It is hard to find a problem like this from a book. Alright, so that will be the end of this video. In the next video, I will give you a couple examples regarding the application of root tests. So if you think my instruction is helpful, let me know in the comment section below. Subscribe to my channel, like the video, share the video for me please. Appreciate your help very much. So I will see you all in the next lesson. Signing out for now.